A transversely isotropic fiber composite has the following elastic moduli. E1 equals 50 gigapascals, E2 equals 50 gigapascals, E3 equals 5 gigapascals, nu12 equals 0.25, nu23 equals 0.30, G23 equals 10 gigapascals. What are the values of the compliance matrix S? So in this question, we're giving the engineering elastic moduli, the Young's modulus, the Poisson's ratio, the shear moduli, and we're asked to find the compliance matrix S. So we need to find each of the components, S11, S22, and so on. We're told the composite is transversely isotropic, and we notice that if we look at the elastic moduli, the Young's moduli in the 1 and the 2 directions are the same. E1 is equal to 50 gigapascals, and so is E2, and the composite is isotropic in the x1, x2 plane. So let's just start off by writing down that the composite is isotropic in the x1, x2 plane, since E1 is equal to E2. And then we can start calculating our values of the compliance matrix. We'll start with S1. That's just 1 over E1. That's going to be 1 over 50 gigapascals. And that's 0.02 gigapascals to the minus 1. Then S22 is going to have the same value because it's isotropic in that plane. So S22 is also equal to 0.02 gigapascals to the minus 1. S33 is 1 over E3, and E3 has a value of 5 gigapascals, so that's 0.2 gigapascals to the minus 1. So that's the three values of S that correspond to the Young's modulus. Next, let's look at the values of S that correspond to the shear moduli. So that's going to be S44, S55, and S66. And you remember if we have, say, sigma 4 was equivalent to sigma 2, 3. Okay, so the 4 meant that the shear stress was applied in the 2, 3 plane. And the mnemonic is that those three subscripts all add up to 9. So sigma 4, the 4 plus the 2 plus the 3 adds up to 9. So S44 corresponds to shearing in the 2, 3 plane. And so S44 is equal to 1 over the shear modulus for the 2, 3 plane, and we're told that has a value of 10 gigapascals, so that's 1 over 10, so that's equal to 0.1 gigapascals to the minus 1. Okay, and then similarly we had sigma 5 was equal to sigma 1, 3, and again the mnemonic is the 5 plus the 1 plus the 3 adds up to 9. So 5 refers to shear in the 1, 3 plane. So S55 refers to shear in the 1, 3 plane, and S55 is then 1 over G1, 3. And if the material is isotropic in the 1, 2 plane, then G1, 3 is going to equal G2, 3. Okay, so this is also going to be 1 over 10, and S55 is equal to 0.1 gigapascals to the minus 1. Then finally, if we look at the last shear modulus, we would have the stress would be sigma 6 would be equal to sigma 1, 2. So the 6 plus the 1 plus the 2 add up to 9. So S66, that corresponds to shearing in the 1, 2 plane. And we're not given a shear modulus for the 1, 2 plane, but we do know that the 1, 2 plane is isotropic. So here we say that the 1, 2 plane is isotropic, and we can use our relationship between the elastic moduli to get the value of the shear modulus in the 1, 2 plane. So the equation is that the shear modulus in the isotropic plane, the 1, 2 plane, is equal to the Young's modulus in that plane, so we'll just use E1, divided by 2 times 1 plus the Poisson's ratio in that plane. So we're going to take nu 1, 2, and we're given the value of that as well. So here E is our 50 gigapascals, and we're dividing by 2 times 1 plus 0.25. And if I calculate all of that, I find that the shear modulus in the 1, 2 plane is 20 gigapascals. And that means that S66 is then equal to 1 over 20 is equal to 0.05 gigapascals to the minus 1. So that now gives us the three values of S that correspond to the shear moduli. And now we want to get the values of S21, S32, and S31. Those are the last remaining values. And from the lecture notes, we had that S21 is equal to minus nu over 1, 2, minus nu 1, 2 over E1, and that's equal to minus 0.25 over 50, and that comes out to minus 5 times 10 to the minus 3 gigapascals to the minus 1. And we have S32 is equal to minus nu 23 over E2, and that's equal to minus 0.30 over E2 is 50 gigapascals, and that's equal to minus 6 times 10 to the minus 3 gigapascals to the minus 1. And then the last constant we're looking for is S31 is minus nu 13 over E1, and that's equal to minus 0.30 over 50 again. It's a 3 there, that's a 50 there, and that's minus 6 times 10 to the minus 3 gigapascals to the minus 1. So that gives us the values of the compliance matrix for the transversely isotropic fiber composite. That's the end of example 1 of week 3.